As Maria mentioned, I work for APA, the Engineered Wood Association. For those that you don't know, APA is a nonprofit trade association representing manufacturers of a variety of common structural engineered wood products. In addition to quality verification and product testing, APA conducts research to improve engineered wood construction systems and educates users and specifiers on the product's proper use and potential applications. As Maria mentioned, the topic of today's webinar is advancements in force transfer around openings for wood frame shear walls. This seminar addresses a joint research project of APA, the Engineered Wood Association, the University of British Columbia, and the USDA Forest Products Laboratory to examine the variations of walls with code-allowable openings. APA tested full-scale wall configurations in conjunction with analytical results developed by the University of British Columbia to develop and refine rational design methodologies. This presentation updates that research with a focus on asymmetric piers and multiple openings. Let's start with our learning objectives. We'll begin by investigating the past and current methods for determining force transfer around openings using wood shear walls. For rational analysis, there's a variety of methodologies available that engineers use regularly. We'll also look at the effects of different size openings and full height piers, the different code allowable height to width ratios, different sizes of openings, and how that impacts the force transfer and the performance of the walls. Focus on the new design methodologies to accurately design multiple openings with asymmetric piers. Too often we have design examples that are perfect world with a small opening with equal piers on either side, which doesn't match reality. So our goal is to match what's being built in construction and more accurately for your purposes in the office. Lastly, we'll look at deflections of these perforated shear walls and what is the best way to do so. Our agenda today matches our learning objectives. We'll begin by looking at the shear wall design challenges globally, look at the history of our research to date, and then focusing again on the advancements we have made with FTAO, where we are looking at asymmetric piers with multiple openings, C-shaped panels, deflection calculations, and conceptual keys based on a recommended design methodology at this time. And we'll review the benefits of these advancements. I'd like to first start by addressing some publications that will be referenced during this presentation. Chapter 16 of the IBC governs the structural design of building and structures regulated by code. Section 1609 specifically details the wind load requirements be in accordance with Chapter 16 to 20 of ASCE 7, and Section 1613 details the earthquake loads be in accordance with Chapter 11 through 15, 17, and 18 of ASCE 7. Chapter 23 of the IBC provides minimum requirements for the design of buildings and structures that use wood and wood-based products. Section 2305 requires structures using wood frame shear walls or wood frame diaphragms to resist wind, seismic, or other lateral loads to be designed and constructed in accordance with AWC special design provisions for wind and seismic, which I'll likely refer to as SPDWS throughout the presentation. SPDWS is available as a free view-only download on the American Wood Council webpage shown here, so you can go to awc.org and download a copy of this for your own use. By definition, under Section 202 of the IBC or IRC, wood structural panels include plywood and oriented strand board. So going forward, when I use the term wood structural panels, it is intended to include both plywood and oriented strand board products. The shear values are a function of panel thickness, fastener size, and spacing. SPDWS 4.3a provides nominal unit shear capacities for wood frame shear walls using wood-based panels. The lateral force resisting systems tend to be one of the most challenging aspects of the structural design of a building. In today's wood frame construction, designers consistently see larger buildings combined with bigger and more numerous window and door openings. This construction trend usually translates into reduced areas for lateral resistance throughout the structure. As we are looking at addressing shear wall design challenges, a lot of the examples that you see tend to be simple structures with uninterrupted shear walls. However, in real life this is rarely the case. In today's wood frame construction, designers consistently see larger buildings combined with bigger and more numerous window and door openings. This construction trend usually translates into reduced areas for lateral resistance throughout the structure. But before we focus on FTAO, let's look at our full spectrum of shear wall choices per the special design provisions for wind and seismic, which is part of AWC's National Design Specification for Wood Construction. In SDPWS Section 4.3.5, it defines the different shear wall options you can use, such as segmented approach, a perforated approach, and forced transfer around openings approach. We will compare and contrast these to begin, especially for those of you who do not do wood design regularly. So let's begin with the segmented shear wall as shown on the far left. Your aspect ratio in the past was 2:1 for a seismic controlled design, without a design penalty up to 3.5:1 with a reduction. The code change incorporated in the 2015 SDPWS applies this aspect ratio to buildings nationwide regardless if it's high seismic or high wind, and we'll go into that in greater detail for all of our shear wall approaches.